Lesson 9.9 is on indirect measurement. So we're going to take the skills that we've learned so far in Chapter 9 and we're going to apply it to Lesson 6.9. There's 2 warm-up problems. Pause them, try it on your own, and then we will do them together. Number 1 says find the vertices of the figure after a dilation with a given scale factor of k. So we have our 4 vertices, and we know that the scale factor is 1/2. So what we're going to do is we're going to multiply 1/2 by all of these coordinates. So I'm going to write this as S prime. Remembering whenever we list our image, we have to do that prime mark. 0 times 1/2 is just 0. So S prime is 0, 0. T prime, 7 times 1/2. It's fine if you leave it as a fraction, 7/2, or if you did 3.5, and then -3 times 1/2 would be -3/2. U prime, I take 1/2 times 8, which is 4, 1/2 times 6, which is 3. So our coordinate for U prime is 4, 3. And then for V prime, half of -2 is -1, and half of 6 is 3. So V prime is -1, 3. So remember, with scale factor, all we do is we multiply the scale factor by every single x and y value. Number 2, it says quadrilateral KLMN prime is the dilation of quadrilateral KLMN. What is the scale factor of the dilation? So we're finding the scale factor here, remembering that scale factor is dilation over original. Excuse me. So I can pick any of these points on my dilation, and I know the dilation is the green one because it has those prime marks with it, which tells me that's the image. So let's go with L prime, okay? I'm going to go with the y value here. So I'm going to go with 2 over, then I look at my original, which is L, and I pick that y value, which is 4. 2 over 4. Simplify to 1/2. So the scale factor is 1/2. We could also check, let's say we do it with M and M prime. So M prime, the dilation is at 3.5. And the original, and I'm using the x values here too, I should say. So 3.5 and the x value of M is 7. Well, this again can be simplified to 1/2. So whatever points you pick, as long as they're corresponding, you should get a scale factor of 1/2. Okay, some vocab. Indirect measurement uses similar triangles to find measurements that are difficult to measure directly. So exactly like it sounds. Indirect measurement, we are going to find some measures using similar shapes. And then shadow reckoning is using 2 objects and their shadows to form 2 sides of similar triangles. So that'll make sense in a second when we practice. The first example says a farmer who is 72 inches tall is standing behind a silo that has a height of 140 feet. The length of the silo's shadow is 31.5 feet. What is the length of the farmer's shadow? So first I should say we've talked model over actual. We've talked image over original. We've talked dilation over original. What we're going to do here is shadow over actual. So anytime we're using shadow reckoning, we're going to use shadow over actual. And there's 2 things here that we're working with that we're going to set up a proportion. The silo and the farmer. So I'm going to do shadow over actual as a reminder, and then I'm going to do up here silo and farmer. This is going to help keep things organized. It's always good to make a chart like this when you're setting up these proportions. So my silo's shadow, it says the length of the silo shadow is 31.5 feet. So the silo shadow is 31.5 feet. The actual silo, it says, has a height of 140 feet. And I'm going to set that equal to we know the farmer is 72 inches tall. Okay, that's the actual height of the farmer. We don't know the shadow. So 72 inches tall over figuring out what the shadow would be, or I should say under. Okay, so we have shadow over actual equals shadow over actual. To solve this, we are going to cross multiply. 140 times x is 140x. 31.5 times 72 is 2,268. Okay, I'm going to divide both sides by 140. And it leaves us with x equals 16.2. And since I know that the farmer's height was measured in inches, I know that the shadow is also going to be in inches. So 16.2 inches is the length of the shadow. Double check, does that make sense? The actual height of the silo was a lot taller than the shadow. The actual farmer's height was a lot taller than the shadow. So yep, that makes sense, right? That's proportional. Okay, the next one says, suppose the San Jacinto Monument of La Porte, Texas casts a shadow of 285 feet. At the same time, a nearby tourist who is 5 feet tall casts a 2.5 foot shadow. How tall is the San Jacinto Monument? Okay, so again, we have shadow over actual. And we have the monument and the tourist. So to set up my rates here, let's see. It says the monument casts a shadow of 285 feet. So the monument's shadow, 285 feet. The same time, the tourist, who is 5 feet tall, so that's the actual height, so 5 feet on the bottom for the tourist, because that's the actual, cast a 2.5 foot shadow. So we're going to figure out the actual height of the monument. Okay, a couple different ways you could do this. You could cross multiply. I also see here, the way I'm going to do it is I see that 2.5 times 2 is 5. So I'm going to take 285 times 2. And I get 570, and it should be feet. Okay, so the actual height of the monument is 570 feet. Okay, then we get to the super fun problems. This one says, in the figure, triangle MNO is similar to triangle QPO. Find the distance across the park. So our job is to find this distance of MN. Okay, so I'm going to set up a proportion, and you guys, it's nice to be able to use the picture, but I want you to really try to rely on these order of the letters, because this is going to help us. So I'm going to start with MN over, MN is the first two letters, that corresponds with QP, equals, and then my other measurement that I have here is MO, which, looking at the letters, is the first and the last. So I'm going to take the first and the last from that second triangle, which is QO. Now I'm going to plug in those measurements. X over QP is 3 miles equals MO is 8 miles over QO is 5 miles. Okay, the nice thing about using the letters instead of the pictures is because it helps to keep things consistent. When we look at these two triangles, they're like flipped around, so sometimes it gets confusing as which side corresponds with which side on the other triangle. So really, it's good to rely on those letters. So now I'm going to cross multiply. 5 times x is 5x. 8 times 3 is 24. Divide both sides by 5. And I'm left with x equals 24 divided by 5, which is 4.8 8 miles. Always good to double check here. Looking at MO, so that long way across is 8 miles. So on the smaller one, that's 5 miles, which means across the park should be shorter than that. 4.8 is shorter than 8. So our answer does make sense. Okay, and then last one here, it says using algebra and similar triangles. Given triangle PQR is similar to STR, find QT. So our job is to find QT. Well, QT is not part of a full triangle. So what we're going to actually have to do is we're going to have to find this whole length of QR and minus that 18 meters to just get that X part by itself. So let's start with what we want. So QR, and again, I like to use the letters. So I'm going to look up here. QR is the last two, so that corresponds to TR, equals, and then I look for other measurements that I have. So looking at my triangle setup here, I know I'm looking at the big triangle first because we did the big one on top. So PQ, and that was the first two. So that corresponds to ST. Then I'm going to plug in my numbers. QR is X. We don't know that. TR, actually, hang on, back it up. QR, let's write it as this. X plus 18. Okay, because we do know that QR, the total is going to be X plus 18. TR is 18. Set that equal to PQ is 25. And ST is 15. So now when I cross multiply, what I want to do, I'm going to put this in parentheses here. And I'm going to take 15 times X plus 18 equals, and then I take 25 times 18, which is 450. So then I'm going to distribute. 15 times X is 15X, plus 15 times 18 is 270, equals our total of 450. First thing we got to do to solve this is get rid of the constant. So I'm going to minus 270 from both sides, or add negative 270, same thing. And I'm left with 15x equals 450 minus 270 is 180. Divide both sides by 15. And I get 12 meters as my answer. So 12 is that value of x. If you did, instead of x plus 18, if you just did x for that and solved for the whole length of QR, you would get 30, and then you would just minus 18 from that and get 12 as that x value.